All right, example 6, they ask us to evaluate the sum from I equals to 1 all the way to n, I into 4i squared minus 3. How do we do this? Guys, if you need to mute your mic, guys, please. Okay, I can even do it from my side, so that's okay. Sorry for that. There is a question. Someone asked if there's a significant difference from this model and the original one. The answer is there's absolutely no difference. All right, so you started doing appendix, you went to logic, so we followed the same order. All right, so there is no difference. So maybe the difference will be in the way I assess you guys, but like I said, the content is exactly the same. So don't expect anything easier because it's still the same work that you need to cover. So to solve this, the first step is I can take the I in, so I multiply all 2 by I. You see they have 4i cubed minus 3i. The distribution rule says I'm allowed to split this into 2 different sums. So I have the sum 4 times the sum of I cubed minus 3 times the sum of I. Now we know what this is. Remember, these are identities. These are stuff that you need to be able to remember. I cubed and I, all right? So we know I is n into n plus 1 over 2. I cubed is just n into n plus 1 over 2 all squared, all right? And if you multiply and simplify out, see what happens. Now, please don't stop here because if you stop then you're not done. You need to see what is common. You notice there's an n. So this time the n and n plus 1 is common on both sides. You can see it's common on both sides of the negative sign. So factor out n into n plus 1 and simplify this as much as possible. And you end up with something that looks like this. All right. So if you notice it, we can't factorize it. So we just leave it like that. All right. Is there any question? Someone is asking about payment. Okay, we'll discuss more towards the end of the class. For now, let's get over this quickly so that we start with the complex numbers. Okay, now it gets interesting. So the example 6, guys, you need to take note about that. For example 7, you need to take, you need to take even more note. All right. Yes, someone is speaking.
Sir.
Yes.
Where can we find recordings of the session?
All right, the same link that
where can you find the recordings?
The link that I sent, it takes you to a directory that contains different folders. There is a folder there for videos. All right, I hope everyone is able to access the previous recordings. I mentioned in the link that I sent that use this link to get course materials as well as the recorded session. So everything is, if you follow the link I email, you should be able to get all the course materials, including the recordings. All right, let's move on. Example 7, guys, take note. I've seen this in the past. There is a limit involved, all right? So what you need to do, you need to solve this sum and you need to evaluate the limit as n tends to infinity, all right? There's no need to panic. You just, we expand as usual. So I squared, so if I give you I squared, I over n all squared, obviously you just get the I squared over n squared, all right? And if you multiply in, so if you take this 3 over n, you multiply all 2, you end up with something like this, 3i squared over n cubed plus 3 over n. The reason why I'm doing that is because I want to be able to apply the distribution rule that says I can split this sum into 2 different sums, all right? Now, once you do that, notice it, this is an identity, right? Because we know the sum from I equals to 1 all the way to n of I squared is just n into n plus 1 into 2n plus 1 over 6, all right? The 3 of those identities you need to know for. You need to know for I, you need to know for I squared, and the sum for I cubed, all right? And then this one, the sum from I equals to 1 to n of 1, it just means 1 times n, all right? So you have 3 over n times n, all right? Now, what you need to do next is, so you can see here, n cancels out. So the n is common, so it cancels out. You just left with 3. Then here you need to group terms you need to split the ends, all right? So you see that there are 3 ends here at the bottom. You have 3 ends at the bottom, and at the top you have 3 factors, n into n plus 1 plus 2n plus 1. Now make sure that each of this term here, so each of this term that you have here, gets an n at the bottom. So you see I split it as n over n plus 1 over n, 2n plus 1 over n. And the reason for that split is because we want to be able to evaluate the limit as n tends to infinity. Remember, if you don't split it this way, it will be difficult for you to tell what happens when n approaches infinity, all right? All right, I'm going to explain a bit further. Now, look at what happens here. So if I take out the constant term there, which is half, that's half, n over n is just 1, all right? So 1 times half is just half. Here, we need to split the denominator by applying the concept that says, if you have a plus b over c, you can write that as a over c plus b over c. So I'm just going to show you, demonstrate. So if you have, let's say a plus b divided by some number c, you can split this bottom there. So you can have a over c, and then you still have b over c. So this idea is very critical because it's going to help you to get it in a form where you can easily compute your limits, all right? Without doing this, you wouldn't be able to compute your limit. So let's see what happens. So I'm trying to split this term here. So I have n over n, it's just 1. You see, that's why we have 1 there. 1 over n, that's a 1 over n. Times, remember this bracket means we're multiplying. 2n divided by n, you have 2. Then 1 over n, that's a 1 over n. Now, at this stage, you good to go. It means you can apply your limits. Remember, when the limit as n tends to infinity of a constant is just the same constant. So half stays as half. But look at what happens here. 1 over some infinitely large number is 0. So 1 plus 0, you see that we just have 1. 2 plus some infinitely large number, again, is just 2 plus 0 because 1 over infinity is just 0. All right. So you have 2 plus 0, which is 2. Take note, this dot here is multiplication. And then you just have plus 3. And if you do that, you have 4. Guys, you need to be able to do stuff like this. All right. It's a must. You should be able to do stuff like this. If you struggle, you can send me an email or you can consult with the tutors. All right. I see in the chat area, people are complaining about they can't hear anything. Can someone hear me? All right, if anyone can hear me, can you say yes? Okay, someone can hear me. So I wonder why those students can hear me. So if you can't hear me, just check your volume and make sure that your mic is working and everything is working. Or maybe you have a network issue, because if you have a network problem, then obviously it will be difficult to actually hear me. All right, this is another important one. So there's written homework, but I will do you guys a favor and we'll do it together. It's another telescopic sum. All right. Telescopic sum, how would you know in the test that this particular equation is a telescopic sum? You're going to see stuff like this. All right, you're going to see the difference of 2 terms. So it will be some number over some term there minus some number over another term. So that gives you the idea that you're dealing with telescopic sum. And how do we solve question like this? The first you need to realize is this is not something that you can compute by hand. The reason I'm saying so because we started from I equals to 3. Look at where we stop it. We're stopping at 99. Obviously, if I ask you this in a test for maybe 2 marks, it's impossible for you to sit and try to evaluate from I equals to 3 to 99. That is simply not possible. It would take you at least 30 minutes, all right? So it's simply not practical. So what I advise you to do is to use telescopic sum. The trick here is if the number here on top is very high, it means I'm testing telescopic sum. All right, it's not something that you can compute by hand. All right. And how does it work? You just need to write out the first few terms. I will say 3 or 4. So if I put I equals to 3, notice it, I get 1 over 3 minus 1 over 4. I keep that in bracket. I say plus. I go to the next term. When I is 4, I have 1 over 4 minus 1 over 5 plus. I write the next term 1 over 5 minus 1 over 6. I say plus. You use dots. You say, and so on. plus you write the last two terms. Remember, the last two terms is when I is 98 and when I is 99. Those are the last two terms. You must include those last two terms. Don't just write the last term, because if you write the last term, it will be difficult to make an observation. All right, so write the last two terms at least. All right, if you do that, you have 1 over 98 minus 1 over 99, and when I is 99, you have 1 over 99 minus 1 over 100. Look how the cancellation actually works. So the second term from this first bracket cancels with the first term in the next bracket. All right. Again, the second term there cancels with the first term there. The second term there obviously will cancel with some first term in the future, right? Or in the next bracket. Now we focus on the last two terms. Notice it here, this term here, which is the second term, cancels with this first term. And obviously, because this is a first term, it means I will cancel with some second term from the previous bracket. The only thing that will be left untouched, if you notice it, is 1 over 3 and minus 1 over 100. All right. Let me just leave it in here. All right. So the only terms that will be untouched, you see there's 1 over 3 minus 1 over 100. If you do that, you have 97 over 300. So you knowing telescopic sum saves you a lot of time, because in the test, like I said, it's impractical. You can say I equals to 3, 4, 5, 6, all the way to 99. It's impractical, all right? So you need to quickly see that I'm testing you the concept of telescopic sum. I can tell in advance, I'll definitely test you on stuff like this, all right? So make sure you're comfortable with stuff like this. If everyone is happy, let's move to the next one. The next one, again, you see there, I said is for homework, but since it's a last example, I'll just go over it with you guys. Now, again, you can see it's a limit, as n tends to infinity. So it looks more or less like the example that we did earlier. And the trick was you need to expand all of this out. So 2i over n cubed becomes 8i cubed over n cubed. If you multiply this term here, you just have 10i over n. And then take this 2 over n, multiply in. So take it in here. You have 16 I cubed over n to the power 4 plus 20 I over n squared. And you know what the rule says? The rule says takes everything in front of the sum. All right. The sum of a constant times I, you can just take the constant in front of the sum. So I'll isolate this. I'll split the sum into 2, and I'll take all this constant term here in front of the sum. Remember, n itself is a constant because the only thing that changes is actually I. So you can see they will have 16 over n to the power 4, sum I from 1 to n, I cubed, 20 over n squared, sum I equals 1 to n of I. Now, these are identities. Guys, you must be careful, because if you notice it, this identity says that I must start from 1 to n. Don't get full in a quiz or in a test. If I change this number and I put maybe 2, it changes everything, all right? So please, you must always check that that is the correct identity you use it. It must start from 1 to n, and then if you have I or you have I squared or I cubed, then you know it's the identity. If it starts from 2, I'll give you a little hint, because you might see such in the future. So let's assume that I actually start from 2, all right? But you actually planning to use the identity. So I'll use the easiest one there, which is actually I. So if you notice it, this is not the identity. So you cannot just come here and say is equals to n into n plus 1 over 2. No, because it's starting from 2, not 1. So the ij here is you're going to say that, okay, I can use the identity from 1. So meaning that you say that is n into n plus 1 over 2. But then remember, if you write this identity, it means you're taking the whole thing from 1 all the way to n. But because I'm starting from 2, it means that you need to subtract the first value. So when I equals to 1, remember when I is 1, if you plug in the place of I, you basically get what? So if you go to this formula there, you put I is 1. You have 1 times 2 over 2, which is just equals to 1. There you go. You see, so the trick is, if you're starting from 2, it means you need to subtract the first term when I equals to 1. If you're starting from 3, it means you need to subtract the value when I equals to 2 and when I equals to 1. All right. I hope you guys will remember this. If you don't remember, then obviously in some future assessment is going to deal with you. All right. So we can see I cube, I just said the identity is a squared one. And then for I is just n into n plus 1 over 2. We all know the identity by now. Multiply out as much as possible. Now in this stage, guys, the trick with this question is some people normally get to a stage like this and then they stack, all right? They don't know how to get to this final answer. You use the same idea that I mentioned. There's n to the power 4 here, and you have n squared, you have n plus 1 squared. Split this n. So n squared gets 1n squared, and then you'll be left with 1n squared at the bottom. Just take it inside this bracket. So you have n plus 1 all over n all squared. All right. If some of you are asking, where is that whole thing coming from? If I have a squared over b squared, obviously I can group them together, and I just say this is just a over b all squared. All right. So it's just the whole thing here all squared. All right. So it's the same idea that applied here. So I had n plus 1 squared divided by n squared. So I just choose to group it by saying n plus 1 over n all squared. All right. And here, notice it, this n here will cancel with 1 of n here. And you take the other n inside here. Why are we doing this? Because we want to apply that same idea that a plus b over c is a over c plus b over c. So I'll say n squared over n squared is 1. 1 times 4 is 4. So we have 4 there. N over n is just 1. 1 over n, that's just 1 over n, plus 10 times. Again, here you have to split the bottom. So if you split it out, you have n over n again, which is 1. And they have 1 over n. And now you're good to go. So from this stage, once I see that you get to this step, it's just not possible that your final answer can be wrong. Once you get there, your final answer will definitely be correct, because as n tends to infinity, a constant over some very large value is just 0. So you just end up with 4 times 1 squared, which is 4, 10 times 1 plus 0, which is just 10 times 1, which is 10. You just have the value of 14. All right. Okay, if everyone is happy, then you have homework. Please make sure that you do the homework. So they have some homework exercises. Make sure you can do them. You can see there is a telescopic sum there for question 4. So practice, make sure you can do stuff like this. All right. Everyone seems to be happy. So we have about just under 10 minutes before we have to switch to the second Zoom session. So I'll just introduce Appendix before our time runs out. Appendix H. So I'm introducing Appendix H now. Appendix H is complex numbers. Guys, what I'm showing you here and the homework I'm giving you and the thought I'm giving you, it covers more or less what I'm going to test you. So if you feel that there's something that is not necessary for you, you're going to leave them away and then focus on something else, you'll be surprised. Because once your tests come, you see stuff that we've actually done in class. All right. So make sure that you actually do all the examples, all right, that I'm doing with you in class, and all the homework that I actually give you, including the TAT. All right. So complex number can be represented by this expression. So for a complex number, we can write this as a plus bi. Now, something you need to take note, I squared is just equals to -1. And we say this a there is the real part of your complex number. And b there is the imaginary part. You see, imaginary part is associated with that I there. So you need to watch out. So if I say, for example, 2 plus maybe 3i, obviously it's easy for everyone to spot what a and b are, but sometimes I can choose to actually write it like this, 3i plus 2, all right? So your real and your imaginary part had nothing to do with which one comes first and which one comes second. It has to do with what number doesn't associate or doesn't contain any I. That is the real part. The number that contains the I is the imaginary part. So these two things are exactly the same. All right. So please, I've seen that in the past, people assume that the real part comes first, the imaginary part comes second, and then they end up doing the wrong stuff. Example 1, we just need to multiply these two out. That's easy. So you take -1, you multiply this whole thing by -1, and then you take 3i, you multiply again this whole thing here with 3i. So you can see the -1 times this, 3i times this. And if you multiply out, group like terms together. So keep all the real parts together and the imaginary parts together. So if you notice it, if you multiply 3i times -5i, there you get -15i squared. And what is I squared? I squared just -1. That's what I mentioned in the beginning. All right, I squared is -1. If you do that, you just have 13 plus 11i. If you choose to write it as 11i plus 13 is fine. I'll still give you your mark. But please don't get confused if I switch this two around. So I write it as 11i plus 13. All right, it doesn't change anything. All right, let's move to example 2. For example 2, they want us to express this in the form a plus b. I can tell you in advance, these are the kind of stuff I like asking for my quizzes. These are basic examples I should be able to do. Now, if you notice it, I want to move from this to this complex form, which is just a plus b. How do I do that? We use the idea of complex conjugate. What do I mean by complex conjugate? Complex conjugate of a number z. So let's say a complex number is given by z. Let's assume that z is equals to this value that we have here, a plus bi. All right. The complex conjugate by definition is now equals to a minus bi. Okay, I'll explain that. Complex conjugate says that go to the imaginary part and negate the sign that you see in front there. All right. So if it was plus, you just change it to minus. So to solve this kind of problem, you always focus on the bottom piece. So our focus there is the complex number there at the bottom. We're going to multiply top bottom by the conjugate, complex conjugate of that complex number there at the bottom. And what's the complex conjugate? Notice it, you have plus 5i, means you need to change this plus to a minus. That becomes a complex conjugate. You can see I have 2 minus 5i divided by 2 minus 5i. Remember, it doesn't change anything. If I give you a complex number and then you multiply top bottom by the same thing, you haven't changed the original question. All right. The only problem will be when some of you come here and you say maybe you instead use plus there, so you're not multiplying by complex conjugate, which your final answer will be completely wrong. Or you choose to use plus at the top and then you use minus at the bottom. Again, you've changed the whole question. Your answer, you basically get a 0. All right, so it's easy as that. So identify the complex number that is at the bottom, multiply top bottom by the complex conjugate of that complex number. If you multiply out, notice that at the bottom here, I basically disappears. So if you simplify this bottom piece, I is going to disappear. All right, you end up with 29 at the bottom. So it becomes easy now to split this into two pieces. So you have 13 over 29 plus 11 over 29i. All right. Remember, I want it to be in this form, a plus bi. So you can't stop here because this is some a plus bi over c. All right. I want in the form a plus bi. So make sure you split the bottom there. All right. If everyone is happy with this example, let's see if we can do one more. All right, before we get there, let's look at some properties of complex numbers. All right. Now, the word conjugate that I've been using is basically just a reflection about the x-axis. All right. So what does that mean? I give you a complex number z equals to a plus bi. The conjugate, remember I said you just need to negate this negative, this plus to become minus. You can see that at the bottom. That is equivalent to just reflecting about the x-axis. All right. When we talk of x-axis on a complex plane, we're talking of the real axis, actually. All right. So you're reflecting on this line. All right. And then another property is the conjugate of the sum of two complex numbers is the sum of the conjugates of each of those complex numbers. And obviously, the conjugate of the product is the same as the product of the complex numbers. And you have the conjugate of some complex number to the power n. You can start by taking the conjugate before raising it to the power n. All right. And then there's something called modulus or absolute value. All right. The modulus or absolute value of a complex number is just the square root of the real part squared plus the imaginary part squared. All right. So if you notice it, your modulus will always be positive because you can't have square root of some number and then you have a negative result. You'll always be positive. All right. And any complex number times its conjugate, all right, gives you the modulus squared. All right. Hence, the reason why in the previous example that we did, I emphasized that you need to multiply top bottom by the complex conjugate. Because once you do that, this property is going to apply. All right. The imaginary part is going to disappear. Because if I take square root of a squared plus b squared, and then I square that, this whole thing just becomes equals to a squared plus b squared. All right. And notice it, there's no I there. All right. If everyone is happy, then let's look at example 3. All right, example 3. Let's see if we can do that quickly before our session expires. So they say find the roots of this equation. Find the roots of the equation, obviously, because it's quadratic, you use minus b plus or minus square root of b squared minus 4ac over 2a. Everyone remember that formula. If you do that, you end up with something like this. Now, the trick here is that I don't want you to tell me that there's no square root of a negative number. Because you've done complex number where you see negative, you can replace it with I squared. Square root of 3i squared just becomes square root of 3 times I. And if you split the bottom there, you have minus half plus or minus root of 3 over 2. All right. So the fact that we've done complex number, I don't want anyone to tell me in the future that there's no square root of a negative number. All right. So if I ask you what's the square root of minus 1, don't say that it's undefined. Tell me that is equals to I. All right. Because you know minus 1 is I squared and square root